Okay. Hello everybody. It's great to be here in the smartphone capital of the world. Of course, it's a very exciting time for us with Chrome to come and visit you and talk about HTML and web technologies. Today, my name is Alex Danilo. My colleague AG couldn't come here today, unfortunately. So you can follow me on Google+ or Twitter or anywhere on the web. So today, I would like to talk about the future of mobile HTML and web technologies. We're going to have a whole lot of different slides. Each slide will cover a different aspect of mobile APIs, and there's a little guide here with a color coding. Now this color coding tells you if the feature is ready, or if the feature is coming soon, or if it's in the long distance horizon. And we also have per browser color coding as well. But before I start with that, I'd like to show you a website that you should all go to. This website is chromestatus.com. Now, chromestatus.com covers all of the new APIs that are on web browsers and web technology. So it's not just Chrome, but it covers Chrome, Safari, Internet Explorer, Opera, etc. Now, what you can see here is a whole lot of different features, and you can actually click on each of them and have a look at the status, and there's color coding. If you would like to understand the guide to the color coding and the browsers, just click this little question mark. It brings you up a whole guide of what the color codings mean, the various browser maturity levels, which browsers support which API, etc. And this makes your development life easier. What's interesting is this entire dashboard here that you're seeing for Chrome Status is built with Polymer, and Polymer is a fantastic new UI toolkit being built for the web, and the talk right after mine will talk all about Polymer, so keep that in mind when you play with this and explore it. Okay, so today we're going to be covering mature features and immature features. So I'd just like to show you that if you have a phone, if you have a real phone, like this phone here, if you go to Chrome and you type in, oh, I can't quite read that, Chrome flags. In there you can see lots of different experimental features you can enable in Chrome for Android. So if you choose to use those experimental features that aren't quite mature yet, then all you do is turn on Chrome flags, turn on the experimental feature, try it out, build sites, prepare for the future. All right, the difference between a desktop web application and a mobile web application is the size of the screen. That's the main difference in criteria. This makes development difficult. Who has difficulty developing for mobile devices? A few people over here. I'm sure everybody does. All right. I'd just like to cover a few things that are very important when developing mobile web applications. One is this Viewport meta tag. Now, when you're developing a desktop site, normally you specify a very wide content width. You may specify 1,000 pixels as the width of your content. Now, the browser on the phone doesn't look any different to the web server. So when you serve the content, it shrinks and the text is completely unreadable. If you use the meta tag using the viewport attribute, or the viewport meta tag, you can actually define the size of the content so that the mobile browser can make intelligent decisions on how to scale the content so your users can actually read it. Now, I won't go into too much detail about how to use this, but this is very mature. It's in all mobile browsers, and there's a nice demonstration here at this URL at the bottom that you can look at. Okay, device adaptation. This is coming very soon. What this does is leverages CSS to do the viewport adaptation. So the meta tag is old style. The new style will be controlled by CSS. And this is much more versatile. And this is already in Chrome and in Internet Explorer Mobile, so keep an eye on this for the future. Okay, today we already have media queries. Has anybody in the room used media queries? Put your hand up. Yes, people have used media queries. Excellent. Now, media queries are a really great way to change the content on your mobile site depending on the device that is reading it. So it's very easy to develop a desktop site that will look great on mobile by leveraging media queries. Now, this is another very nice media query. You can actually detect the orientation of the device. As you can see here, when we change the orientation of our phone, the content actually rotates and changes in response to the orientation we have of the phone. So when I grab my device, if I grab it and I flip it, you will actually get a different visual appearance. This also is in every mobile browser, so you should be using it if you need it. Now, another very interesting new feature that is here in all the browsers on mobile are viewport units. Now, people who are used to positioning content on their screen using percentages, that's percentage of the containing block or percentage of the whole page. If you use viewport units, these are percentages of your actual screen real estate. So here, 30 VH is 30% of the height of the viewport. So you can choose the height of the viewport, the width of the viewport, the minimum dimension of the viewport, or the maximum dimension of the viewport. Another fantastic new model in CSS3 is Flexbox. CSS3 Flexbox, Flexible Box module, lets you separate your content from your layout. The beauty of this is that your HTML content can be logical in order, so your story is semantically unchanged, but when you put it on different devices, you can change the layout completely. You can swap order, swap location, independent of the original HTML content. So this is a very, very good way to change. If you have a desktop site, for example, with navigation at the top, content in the middle, extra content at the bottom, when you shrink to a smaller device, you can move the navigation or move the stuff at the top down to the bottom and have the center content as the first thing that your mobile user reads. All right, now here is a very interesting new feature which is coming now. It's already in Chrome and Opera. This is Position Sticky. Now when you do a CSS layout with fixed positioning, you can anchor something to the screen in a set location. This lets the user scroll the content around and have something that is static, but that's very limited. With the sticky positioning, you can actually associate one piece of content to another block of content, and as you see here, the capital letters are anchored to the content within them. So as we scroll, you can see that the sticky content sticks to the top of the screen and then scrolls off. This lets you build UIs that are very similar to native UIs, just using web technologies. So this is a very nice feature that's coming to mobile browsers. All right, there's this great looking man here who features in all of my slides, who's showing you here the Fullscreen API. If you're trying to build immersive HTML5 games, you need to be able to take over the entire screen real estate of the browser. This used to be done using window.scroll2.01, which was a bit of a hack. That is no longer the correct way to do this. There is now a proper JavaScript API which lets you do full screen. Now, when full screen is enabled, the only way to enable full screen is by user interaction. So your user has to tap or click or perform some kind of interaction to actually create the full screen experience. So JavaScript can't suddenly pop up and take over the screen and look like another application. I'll demonstrate that shortly. So Everybody's walking around with phones. Who has a smartphone? Oh, come on. This is Korea. Everybody has a smartphone. Right, you're walking around, so what can you do? How do you build a better experience for your developers when you're walking around with a smartphone? What you need is to take advantage of the fact that the phone is in your pocket. So the way you do that is provide services and web applications that take advantage of what the browser knows. Now the browser knows where you are, and that's really, really useful. For example, if you've got a mapping application, you can actually use the browser to say, I am here, and get the correct map for where you're standing. Or if your application is searching for restaurants, you can use the geolocation to search restaurants within the local area. Now, this is a very, very easy API to use, as you can see. You can just get the latitude and the longitude. In fact, you can set a listener. This bottom little piece of code here lets you have a JavaScript listener that listens to changes in position, so you can dynamically update your location. So it's easy to build something like a tracking application for when you're riding your bicycle that shows you where you are, and as you ride, you move on the map. And this is in every mobile browser today, so you should use this. Now here is another one that's very interesting. Because these devices have accelerometers and gyroscopes, when you move them around, the browser can actually detect that motion, and you can use device orientation to build all sorts of experiences. So I'll just show you a little example. Okay, so here is my Chrome browser. Now, as I said before, we have the Fullscreen API, which takes care of the full screen. We have device orientation. So if I tap the start button, right, it goes into full screen, and we have this full screen experience. And if you'll see, there's a little Chrome ball that rolls around. And so this is using device orientation to basically play a little ball game. So we can roll around. Now, little Chrome rolls around. So we actually have a full screen HTML5 game here, using device orientation to run the ball around and hopefully score more points. So these are real APIs you can use for HTML5 gaming. We have a session later on in the day which does a deep dive into HTML5 gaming, and the fact that we have these device accesses and we have the full screen, you can actually build powerful HTML5 games in modern browsers on devices today. Another interesting thing that you can have that is now in browsers is the ability to detect if you're connected to the network. There are JavaScript events which tell you if you are connected to the network or if you're disconnected. So you can make intelligent choices about what to do when the user is offline. So if you put your browser or your phone into airplane mode, you know immediately that you can't get the network, so that you can make smart choices about what you present to the user. And so when you reconnect to the network, you will get an event. When that event hits, you could do something like synchronize to your server or things like that. So these are important ones to know about. It's also important to understand the online-offline status is just connection to the network. It doesn't mean you can get to your web server. All right, now storage APIs are a very interesting picture today on mobile browsers. There's a lot of variation between the browsers. We have local storage everywhere, but local storage is restricted to very simple storage, small amounts of data. There is no query or lookup, so it's pretty stupid, or pretty simple, I should say. We have these two other storage mediums. We have WebSQL and indexed DB. Now, WebSQL was an old standard that is now deprecated. So we encourage people to give up on WebSQL because it's going away. It's no longer being standardized. but it is in a lot of mobile browsers today. IndexedDB is also in a number of mobile browsers today, is much more recent. It's also the standard that is going to be used going forward. So we would recommend as a mobile developer you look at IndexedDB, learn the APIs, and of course you can see the feature table here, how IndexedDB is not supported on the Android browser or on Safari for mobile. So the simple solution to that is to use abstraction libraries. So here are 3 abstraction libraries. They hide all the detail of the implementation from the developer. So you as a developer, you can just write using one of these abstraction libraries. If the browser supports IndexedDB, it will work straight to IndexedDB. If the browser doesn't support IndexedDB and supports WebSQL, it would perform the translation for you. So this is the easy way to solve mass storage on the phone. All right, now here's an interesting aspect of phones. Who here has written a book? Oh, we have a few book authors here. Excellent. At the back. Excellent. How many of you wrote that book on your phone? Nobody. That's funny. I always write books on my phone. Nobody writes books on phones. In fact, it's a horrible experience typing on a phone. It's slow, it's painful, and your users, the users of your applications don't like typing just as much as you do. So when you design your web applications and your websites, you should use semantic input types. So here you can see there are many different input types that you can apply to your content. So we see, just take the first one for example, input type equals email. When you specify type equals email on your phone, the keyboard that's presented to the user has the @ sign. If you see down the bottom left, there's the symbol for @. So it's a keyboard tailored to typing in email addresses. Same thing for search. You get a nice little magnifying glass to search. Telephone numbers lets you brings up the phone keyboard for phone number entry, etc. So these semantic types do one thing, and the one thing is they save your users time. Right? Your user doesn't have to fumble around finding the right keyboard, switching modes. The browser does the work for you. And so if you have a look at the date types bring little spinning things for days and months. What do we have here? We have a search one with a magnifying glass. It's a beautiful video, this. The phone one. Now if we have a look at the number one, which is next, the interesting thing about this is with the number input type, you can specify a number range. I can say range from 100 to 200, and the browser will do the checking that it's valid. All right, now here is another very interesting feature of phones. Today, all phones are touch phones, or all phones that matter. The thing about touch phones is that touch phones are fairly new. Browsers were developed in the days of mouses and keyboards. And so the events that come in for touch are really tailored for an era beforehand, a long time ago when everyone used a mouse. Because of that, there is a 300 millisecond delay if you tap on a link in the browser before the actual link gets activated. Now that's a huge problem with development, and later on in the day we will show you how to fix that. In fact, Jake will, wherever Jake is. So keep that in mind. But there are a number of demos with this, and the thing that's interesting with the touch events is that you can detect movement and touch end, and you get a lot of events, and they're very, very inaccurate. So when you touch, it's much less accurate than using a mouse. In fact, quite often the touch start and touch end will be at different positions even though you haven't moved your finger. So keep that in mind. Now, everybody realizes that touch events and mouse events, being from different backgrounds, have problems. So Microsoft made a proposal to W3C for a thing called pointer events. Pointer events unify mouse events and touch events. So what they do is they provide a common framework for both mouse and touch, and it's a very, very nicely distilled kind of combination of both. Of course, the problem with pointer events is only one browser supports them. People have been building JavaScript shims to actually simulate pointer events, and there is a lot of activity to bring pointer events to other browsers, but it is one to keep in mind for the future. All right, so we'll get on to what is different about a phone and a computer. So what's nice about the phone? Can anybody suggest anything? All right, I'll suggest it. How about we have a camera? We've got a camera in the phone, so I can take photos. Now look at that. Now, as we said before, we had input types and we have the semantic types where we set telephone, email, search, etc. If we actually play with the input type and tell it we want to take a photo, the browser will detect the camera in the phone. And when you activate that input, it will actually go directly to the camera. Now, if I had no camera in my phone, it would go to my media gallery and let me browse a photo out of my media gallery. So the media capture in the phone lets you actually grab photos, use the camera from your web application. This is a very, very powerful thing. You could use it for Instagram style sites, for example. Now, another feature which is coming along is called web audio. Now, web audio is a very powerful audio signal generator. This lets you create notes, synthesize things, do all sorts of fancy effects. It's very new. It's in Chrome, Safari, and Opera, but it only runs on high-end devices. So devices that support the Neon ARM extension. So Neon is like a separate CPU core specifically for signal processing, and all modern smartphones have the Neon extension. So this is coming and it will become really, really popular, especially for games. Now, another interesting thing which is really, really good is Get User Media. So Get User Media lets you grab your camera and then use it on your phone from JavaScript. So what this does is you place a video element on your page, you say Get User Media, which gives you a JavaScript object. You attach the JavaScript object to your video element, and that lets you play video directly on your web page, coming from your camera. Now you can do all sorts of things like grab still frames. So if you connect that video to a canvas element, you can grab frames out of the video. So you can do all sorts of amazing things with Get User Media. But of course, it will ask the user permission for using the camera first. Now, who's heard of WebRTC? A few people. Web real-time communication. This is possibly one of the biggest new technologies in web and mobile web to come in recent times. WebRTC allows true peer-to-peer connection. So you can transmit audio and video peer-to-peer. But one of the best features of this, which is not well understood, is the RTC data channel. Now, you can send video, audio, and data. So you can send, game data or files or anything you like. Now, the beauty of the data channel is it has very, very low latency, has guaranteed 100 millisecond latency. So for multiplayer gaming, you can use WebRTC, use the data channel to have fast update of your gameplay. There are many applications, and we probably can't even imagine most of the applications for this, but there are a number of examples of it, and so you should try it. And it's in Chrome, it's in Firefox, it's in Opera, and so combined with all those browsers, there are probably over 1 billion WebRTC enabled clients out in the world today. So keep an eye on this one. Of course, we all love games, and who can't love WebGL? So WebGL is available from Chrome 30 onwards. It's out there, it's limited on mobile, but it is there and it does perform. So here's a random example that Paul found somewhere of somebody doing an interesting thing in WebGL. But WebGL lets you access the GPU on the phone, on the device, and do high-speed, fully accelerated graphics. Something you should definitely experiment with if you like playing games or you like fancy 3D. All right, this is a new feature. So add to home screen. Who runs web applications as an icon on their phone today? Not too many people. Now the reason for that is it's always been a bit difficult. So all right, I'll just give you another quick little demo here. So here we have Chrome again. So I found this nice web page. This is a really cool web page. It tells me what the forecast is, right? It tells me the forecast here. It uses geolocation, so it knows where I am. It pulls up the current forecast, and I really would like to use that every day. So if I just select my menu and press Add to Home Screen down here, and give it a name, and then lo and behold, it appears on my home screen. Look at that. So now we have an icon that is an actual web application. Now if I try and start it, it starts as a full screen web application. So now we have fully installable web apps as first-class citizens on Android through Chrome. Now Add to Home Screen is very new. It's in Chrome Beta. It will be in Chrome Stable very soon. But the beauty of this is that the applications start full screen, so they look like a native application. They have an icon. You can select the icon. And it means if you're an HTML5 game developer, for example, you can build a full screen application, uses the device, uses the camera, looks like a complete native application and runs beautifully. You can even leverage WebGL if you need high performance graphics. Now, another feature of mobile browsers that most people wouldn't know about is the use of Android intents. So when you have URLs, you can specify the target that you're trying to hit. So normally you jump to a website or you jump to something else, but you can actually specify an intent. So if you see here, we've set an intent of a barcode scanner. So that markup in your web page tells the browser, I actually want to use whatever application scans barcodes. And so in this case, we've actually set up the intent to say, oh, scan, etc. You can look at the example at home. But it tells Android to go off and find the proper application to handle my request. This is all done through the intent URL. And this is available today, of course. All right, now this is going to be the subject of a number of talks today. Performance matters. Everything is slower. Now, when we look at this, I'll just talk about this in a moment. The speed of a mobile phone today is approximately 1/10 of your desktop machine. The speed is not just the CPU. The speed is memory bandwidth, the CPU, the high resolution screens we have today. We have full HD mobile phones today. But the network is probably one of the biggest pain points. Network connectivity in 2G and 3G networks has very, very high latency. Once 4G becomes common, then that will be greatly improved. But for now, the network is one of the slowest components in getting a web page from your server to your client. Now today we have this navigation timing API. Now if you have a look at the typical loading of a web page, if you choose a URL and wait for it to show, there are all these times. There's the network time, there's the load time from the server, then there's processing before I see anything. Now this is a big black box. It's very, very hard to understand what is happening. So now we have this navigation timing API. This API breaks down all the steps in the loading of your web page. You can see your DNS lookup, you can see your cache loading, you can see establishment of a TCP connection, you can see all the other content loading, you can see the events happening. And so this breaks down your website loading so that you can understand where you need to improve it. So if all the time is spent in server delay, you will see it using this API. Of course, when you load a modern web page, there's a lot more content than just the one web page. You have images, CSS files, JavaScript files. To understand the loading of all the resources that make your web application work, you can use the resource timing API. The resource timing API will actually show you detail for all of the resources you're loading. So if, for example, a CSS file is blocking load of your web application, you can identify it using the resources timing API. It's a very, very useful information, especially for mobile. So the new mobile web that we've all been developing for is pretty awesome. It's very exciting to be part of this, especially in South Korea, because this is the powerhouse of smartphones. But the thing is, what we can do now on a phone, which we couldn't do before, is we can adapt to screen sizes, right? We can use Viewport, media queries, we can change our content depending on the device, depending on orientation. Very useful. We can also handle people on the move. So we can use geolocation, we can use device motion, we can actually make the web application smarter, respond to what we're actually doing, because we're not sitting at a desk. We can really speed up input. The input semantic types for input make your life much, much simpler. Your users will love you if you use the right semantic input types, because it means less typing. The faster they get input, the faster they buy things from your website, or the happier they are. The other thing that I've just shown you that's really, really amazing is integration with features on the device. You have the camera, you have accelerometers, you can grab the microphone, you can do all sorts of things that are like native applications but work straight out of your browser, straight in your web application. The other thing that is really important to do is to measure performance across all devices. And we have a number of methods of doing that. We have the new navigation APIs and the resource timing APIs, which give you more information. Later on today, there will be a number of deep dives into how you can measure graphics performance, etc., which all helps you build a beautiful site that users will love. And all this means is more users. And of course, very, very soon you should really look at all these new features. WebRTC, I highly recommend people explore WebRTC. It'll be a huge, huge thing on the web. Web audio, especially if you want to do gaming or any sound applications, is a fantastic API. And of course WebGL, which is very exciting that it's finally hitting mobile browsers. So that's pretty much a very, very quick overview of all the new APIs that are in mobile browsers today. Feel free to come and ask questions whenever you like. I'll be around all day, so if you have any specific questions, please come and ask. And we have a question now. Yes. Yes. Yes, you.
So you have said the current mobile HTML5 browser supports several features as like utilizing device features. One example you said is that about getting some of the location features. My question itself is that for example, in the Android case, this year is in the Google I/Os. Google already has announced some enhanced location-related features. And what is the difference about the Chrome's approach and the Google Android's native API approach? Maybe if Chrome itself has supported some of the same features that is announced in the Google I/O 2000 this year, maybe it will be very fantastic. But I'm wondering about maybe Chrome itself doesn't support this kind of
Okay.
performance.
All right. Okay, I've got the question. The question was that this year's I/O, Android announced enhanced location features for finding the location on the phone from an application, and whether or not the browsers support that and what the difference is. What was announced was actually the Google Play Services has an enhanced location capability, and what it does is it leverages the accelerometers and motion sensors in the phone on top of GPS. So traditionally the location has been derived from GPS data. The enhanced Android location uses the device motion sensors and accelerometers to get a more accurate picture of the motion of the user. So it supplements GPS, so creates additional accuracy by virtue of the phone's sensors. Those APIs are used by Chrome internally, so the Android platform improvements filter down into the browser. So when you use geolocation in Chrome, it is going through the Android API. So improvements to the Android platform automatically filter down to the browser. Okay? Oh, sorry?
Yes, currently, according to your presentations, the new mobile HTML5 features normally advanced adopted in the just Chrome, not in the Android previous WebKit browsers. So the Google's approach is now the focus in the Chrome, not on the Android traditional browser, based on the WebKit.
Why don't we take that question afterwards? Why don't you come and talk to me after the talk, because it's a little bit too detailed for this high level. Okay. Right. Another question. Yes.
Yeah. You explained several ways to adapt to the screen size at the web application or web page level. But another layer that you can adapt to the screen size is at the HTTP server. You see the user agent screen and solve mobile version or desktop version or whatever. So what do you think about this approach? Do you think that this approach should be gone in future or should be improved or
Okay. The question is about detecting different screen sizes and adapting content to the different screen sizes versus desktop, whether or not to use the features in the browser versus using the user agent string from the server side. We would now highly recommend you don't look at the user agent string and do all the content authoring responsive so that you adapt to screen sizes inside the browser, inside your content. The reason is that the user agent string is incredibly unreliable, and it's very easy for a user to change the user agent string so that you don't actually know the browser properly. So it's a very, very unreliable way to detect the user agent. So media queries and all of the other adaptive designs is really what we'd recommend today. Okay? All right, on that I'll say thank you. Anybody want to come? Oh, one more, last question, yes.
Yeah. Thank you. So my question is concerning to your Homescreen feature.
Yeah.
So as you know, Apple already support Apple Meta Tag. I think that the Homescreen feature of Chrome is very similar with that. So using the Meta Tag, right? But I think that anyway, that could be a fragmentation because there are no standard for that yet, right? So as far as I know, in W3C, web application working group, they try to make a manifest format for web application that is edited by Mozilla guys. So my question is that Chrome team has a plan to support that kinds of standard features for installation of web application.
Okay, the question is about the install to home screen feature, because at the moment it's a meta tag that's Apple specific, and whether or not this is being standardized and work going on with the standardization of this feature. Okay, well now in Chrome we support the meta tags that indicate to an Apple device that we recognize the Apple specific meta tags to enable an install to home screen for backward compatibility. We intend to go forward with a standardization process. We actually mentioned Mozilla as far as install to home screen. There is the co-chair of the Web Apps Working Group who used to work for Mozilla now works for Google in Sydney as of about 2 weeks ago. So we are very active in making sure that we push forward through standardization because we really believe in open standards in W3C and all that. So we will definitely be following that path to standardization. Okay, all right, everybody. Thanks very much for listening and enjoy the rest of the day.